All right. Good afternoon, ladies and gentlemen, or good morning, whatever you're doing. So today I want to talk about compound inequalities and absolute value inequalities. So to start it off, let's talk about two types of notations that you can do. You got set notation and you got interval notation. So I'm going to go kind of quick through this. You might have talked about it a little bit last year, but if you didn't, it's no big deal. First one, this graph, if you remember, that is an inequality. So in set notation, it's going to look like this. It's going to be like a squiggly bracket, and you're going to say x such that x is greater than or equal to 3. Now, in interval notation, since it's inclusive, you can go 3, comma, and it's going to go to infinity. This one is in set notation is going to be the squiggly bracket x such that x is less than 6. And then since it's to the left of forever, you're going to do negative infinity, comma, negative 6 with the parentheses. So this one's interesting. This one is all reals. What does that look like as interval notation? From negative infinity to infinity. This one, you talked about it in probably algebra 2 or whatever. This is an or. So this is curly bracket x such that x is less than 1 or x is greater than 5. Now, what does this look like as interval notation? Negative infinity, comma 1 with parentheses. You're going to use a fancy looking U for union, 5 to infinity. So I know that looks a little weird, but that's what you do. Finishing out a couple other ones. This one is or. Okay, so the or, this one, you're going to, for your set notation, is x such that x is less than negative 7 or x is greater than or equal to 2. What does this look like in interval notation? Negative infinity, comma, negative 7, union, positive 2 to infinity. This one's and. And so this goes from negative 4 to 0 inclusive. So for that, you're going to go x such that, oh yeah, I forgot, x such that negative 4 is less than x is less than 0. It's like a sandwich. And then the interval notation is going to be negative 4 to 0. So that should be review. It's not a big deal if it's not. But that's how you do it. Okay. Now, if you don't remember how to do this from advanced algebra 2 or algebra 2 or geometry, we'll go through it pretty quick. So remember, the rules about inequalities are true. You just only if you multiply or divide by a negative. So for this one right here, first thing we're going to do, let's see here, is combine, well, we're going to distribute. So you got negative 12x plus 6 minus 4x is less than negative 90. So now you got negative 16x plus 6 is less than negative 90. We subtract 6, you get negative 16x is less than negative 96. And then we divide. So we're going to divide by negative 16. But what I do is I circle this. So x is greater than 6. Now, what's this look like? In set notation, x such that x is greater than 6. In interval notation, you got parentheses 6, comma, negative infinity. And the graph looks something like this. 6, open circle, shade to the right. Right? That's how you do that one. Try another one. This one, let's see. So you got variables on both sides. So I'm just going to combine my like terms here. So I get negative 8x minus 2 is greater than or equal to negative 8x minus 2. Right? And then I add 8x to both sides. I get negative 2 is greater than or equal to negative 2. Wait a minute. That's weird. Well, that means that you have all real solutions And then the interval notation is going to be negative infinity to infinity. And your graph is just going to be this. Literally just everything. Well, that was interesting, right? So um, that's solving inequalities. Uh, when we talk about solving absolute values, that's a little bit different. And of course, there are a couple ways you can do this, but solving absolute values, um, there's a process. So the first thing you do is you want to try to isolate the absolute value inequality, right? You want to create two cases, and then you want to solve both cases. So let's see, how are we going to do? Which ones are we going to do here? Um, so let's do let's do the first one. So we got the absolute value of 5 minus 10a is greater than 15. So for that one, what you're going to do is you're going to set up two things. You're going to do 5 minus 10a is greater than 15. But then you also got to do this. You got to do 5 minus 10a, and you got negative 15, the negative, but you got to switch the inequality symbol. Okay? It's just a kind of a weird rule. So you subtract 5, you get negative 10a is greater than 10. A is less than negative 1, because remember you divided by a negative, and then you're going to say or, and then you subtract 5 and you subtract 5 and you get negative 10. A is less than negative 20, and you got A is greater than 2. All right? So then this would be, if you're going to write it out, you're going to say curly bracket A such that A is less than negative 1 or A is greater than 2. And then this would look like negative infinity to negative 1, union with 2 to infinity. And your graph would be like at negative 1, open circle going this way, and a 2, open circle going that way. So that's how I know it's an or. All right? So that's how we know it's an or. This also, right here, kind of indicates it. That's going to probably most likely be an or at the very, very beginning. All right? Let's do a couple more with this. So here's one. Negative 4 plus the absolute value of x minus 3 is less than or equal to 0. So first thing you want to do, you're going to want to add the 4. So you want to isolate. So you got this. And now set it up. You got x minus 3 is less than or equal to 4. And then you got to do x minus 3 is greater than or equal to negative 4. All right, so then you add 3 here and you add 3 here, you get x is less than or equal to 7. Then you add 3 here and you add 3 here and you get x is greater than or equal to negative 1. So what does that look like? That's an and. How do I know? Because it started out here, but it's also because it's sandwiched. So you could write this as x such that negative 1 is less than or equal to x is less than or equal to 7. What does this look like in interval notation? Negative 1 to 7. And then what's my graph look like? Well, you got a solid circle at negative 1 and a solid circle at 7. And you fist bump them. All right? Let's try one more. Let's try one more. So this one, first thing I don't like is I'm going to multiply everything by 4. So I got the absolute value of 12 minus 4x is less than or equal to 8. This is going to be an and. How do I know it's going to be an and? Because it's less than. If it's greater than, it's going to be an or. So let's split it up. 12 minus 4x is less than or equal to 8. 12 minus 4x is greater than or equal to negative 8. So then you subtract 12 here, you get negative 4x is less than or equal to negative 4. Divide, flip, you get x is greater than or equal to 1. This guy, you minus 12x, you get negative 4x is greater than or equal to negative 20. Divide by 4 and flip, you get this. So now what you got? You got x such that 1 is less than or equal to x is less than or equal to 5, which I'm not a big fan of that notation. I prefer my my interval notation like this, and my graph looks like 1 and 5, and they fist bump. So that's how you do those. That's solving absolute value and solving compound inequalities. But just remember, if you multiply or divide by a negative, you got to flip, and then you got to do two scenarios. Hopefully that makes sense, and may the force be with you.